Okay, for question 15, it says that a heater coil with a resistance of 34 ohm is connected to a 240 volt AC source. Determine the average power used, the maximum and minimum values of the instantaneous power. So average power used is basically your P average. Maximum would be P naught and minimum is P minimum. It says that a heater coil with a resistance. Okay, so heater coil, you don't have to draw the coil like that. This one is basically a resistor. This resistor produces the power, and the resistance here is R equals to 34, and the Vrms, because this is the V source, that one is Vrms equals to 240 volts. Okay, they ask you to determine the average power. So P average, normally I would like you guys to use I squared R. Okay, so in this case you only have one component, so sometimes it's okay lah to use a different formula, but if it involves more than one component, this is the best formula to use, so I'm going to use this one. First of all, you have to find the current. Right, so this is IRMS. IRMS squared R. So to find IRMS, because you only have one component over there, so V is equals to IR. Okay, you can write Vrms because you only have one component. So this one becomes IRMS 240 divided by 34. Okay, so this one will give 7.0588 7.059 ampere. Okay, then you have to substitute back inside the formula. Okay, just write down the formula again. So you will have 7.059 square multiplied by 34. I got here is 1694.20. Okay, remember the unit for power is watt, so W. Okay, and then the next question, they want to find the maximum and minimum values of the instantaneous power. Okay, so I showed you before the graph for P against time. It's basically like this. Oops. Okay, I show you the P average should be in the middle here. So the top or the peak here is your P naught. Okay, so and then previously I already show you the formula. P average, the relation between P naught and P average is that P average is equals to P naught over square root of 2. P naught over 2. So basically P average is half of the P naught. So P naught is equals to, or the maximum power, should get P naught equals to 3388.4 watt. Okay, so this is your maximum power. Okay, for the minimum power, from the graph itself, you can see that the power varies from here to here. So down here is basically your minimum, which is equals to 0. Okay. Okay, for question 16, they give you a circuit consists of resistor, inductor and capacitor. So this one is a RLC circuit lah. And then given that the Vrms is 100 volt, and omega is 1000 radian per second. Okay, the first question, they want to find the current in the circuit. So basically, if I want to find current, unless I have a specific V across the inductor, resistor or capacitor, I have to use Vrms there. So if I use Vrms, okay, to write down the ohms equation, that will be Vrms RMS Z. Okay, so basically I want to use this formula and I can find the IRMS because Vrms is given. Okay, power supply, voltage supply, and then the Z here is your impedance. So you have to calculate Z first. Z is equals to square root of R square plus XL minus XC square. So it will be Z square root of 40 ohm square XL. Okay, you have to find the XL and XC first because they give you L and C over there. Okay, so your XL 2 pi F, I think might as well we use omega L. So it will be 1000 multiplied by 50. Don't forget the milli there. So XL is equals to 50 ohm. Okay, and your XC is equals to 1 over omega C so 1000 multiplied by 50 micron. So your XC will be 20. Unit will be ohm. Okay, you substitute these two values inside this equation. So 50 minus 20 square, so your Z will be 30 square plus 40 square, and you should get 50 ohm. Okay, now you can apply the Vrms equation there. Here, this one, let's copy it down. So your IRMS, which is the current that you want to find, is equals to 100 divided by 50, which is equals to 2 ampere. Okay. And question B, they want to find the power supplied by the source. Okay, to answer this question, you really need to understand what is the difference between power supply and power loss. Okay, so power supply here is basically your power source, also known as apparent power. Okay, seakan-akan power yang nampak seakan-akan diberi, tapi the actual power that you get, which is what we call the power loss, or the real power, is basically your average power. Okay, so this real power and average power is basically the same thing. Okay, just have a different symbol to it. Okay, and the formulas are is the same lah. So PR or P average is RMS Vrms cos phi. Okay, notice that previous question they want to find power loss, so that one you have to include the cos phi. Okay, but this one, power supply or the apparent power, You don't have to include the course fee. There's no course fee. Okay. So remember this. Your P apparent, PA, or power supply, write it down as power supply, also known as apparent power, is equals to I RMS V RMS. Okay, so your I is equals to 2, V is equals to 100, so you should get 200 watt. Okay, this is the apparent power, the supply power. That the actual that you get, you have to multiply by cos phi, which is R of Z over there. Okay.